Welcome back. Last night I was discussing about this problem, and then due to some technical glitches. So due to some technical glitches last night, the discussion was not completed. So I was talking about this problem, and the pictorial view of this problem is like this. 2 points on a Cartesian coordinate is given as this. One point is 2 comma 7. The value of x is 2 and y is 7 for 1 point, and another point is 6 comma 12. So my question is, how many ways we can reach from one coordinate to the other? I mean, from 2 7 to 6 12. So how to solve this problem? Like this. Understand this. If I need to move from this place to this place, I can only have, according to the directions we know, we only have this much of moves. East, west, north, south. There are only 4 directions. And we can move only in 2 directions, either east or north. So let me check. If I take this particular diagram as a graph paper diagram, then like this, and same thing. Then if I consider this point 2 comma 7, then 6 will be 3 4 5 6, like this, for example. 6 is here, and 12 will be, if it is 7 from the plane, I mean the positive quadrant. If it is 7 and 2, then according to that, it will be 8 9 10 11 12. So this place. So 6 12 will be this point. Okay. So how many moves are possible? 4 east direction move are possible. 4 moves towards east. X will be x plus 1 4 times. So 4 possible moves from left to right. Okay. And there are also other moves available. That is north direction move. N, 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 like this. Okay. So total 6 moves are possible, because here it is 6th place. So 7, 8, 9, 10, 11, 7, 8, 9, 10, 11. Oh, so this point will not be the point. So the point will be this point, like above of everything, there will be another point. So this point will be 6 comma 12. Okay. So this point will be that. So total north move will be 6 north moves are available over there. So total number of possible ways to cross this path, reach this path, is how many ways we can write. How many words we can form with these letters. I think one person is there who's watching now. So can you please comment who is watching? Whoever is watching, please comment on the comment section. If anyone is watching, then please comment. Deepak, hi Deepak. So you are watching. So fortunately, you are watching this video. Please share this live session in the. Let me share it. Just a moment, Deepak. Okay, thanks Deepak for staying. So how will these numbers? These available letters. 4 E's are there, 6 N's are there. So total, actually, sorry, this will be 9, because from 7 to 12. So it will be 12 minus 7. It will be 5. So total 5N and 4 possible ways we can reach the place, like this, from 2 to 7, to 6 to 12. Okay, if you have understood, just let me know. I mean, let me know in the comment section if you have understood this problem. So it will not be 6 moves, it will be 9 moves. I mean, sorry, it will be 5 north moves and 4 eastwards move. So Deepak, if you have understood the explanation, just let me know in the comment section. Okay, Deepak has understood. Thank you, Deepak. So this is 9 factorial by 4 factorial into 5 factorial is the total number of moves possible. Okay, so if you have already understood, then let me erase the entire board and let's start again with another problem. Okay, I'm starting with another problem. So this type of problem may come in your exams. Whether it comes or not, if you are interested by doing this kind of problems more, then there are a lot of books available in the market full of these problems. You can follow and answer for those questions. Okay, my next question is, there are 16 people and 2 round tables are available. Round tables are there. So how many ways we can, in one table, total 10 people can accommodate for one table, and another table can accommodate total, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, for example. And another table accommodate total 6 people. So how many ways we can arrange these 2 tables that 16 people can sit? Is my question. How many ways we can arrange? How many ways we can arrange 16 people in 2 tables? This is my question. Okay. I hope, Deepak, you have got my question correctly. No, Deepak. Unfortunately, your answer is not correct. Okay, let me do it for you. Understand this properly. So you have written 16 choose 10. Yes, 16 choose 10 will be there. There is no doubt about it. 16 choose 10. Why? Because out of 16 people, you are choosing 10 people who can sit in one table. All right. Now, in this 10, the arrangement in circular table will be n minus 1 factorial, n minus 1 factorial. So, if I talk about n minus 1 factorial, then it will be 10 minus 1 factorial, 16C10 for table number 1. And for table number 2, the rest of the 6 people, so it will be 5 factorial into 1. Okay, why into 1? Because it will be 6C6. That is the reason why it will be 1. So this is the answer. Why 5 factorial? It means 6 minus 1 factorial. Deepak, you have understood this? All are multiplied. I mean, yeah, there's many ways. Into multiplication is there. Okay, Deepak has got it. So simple explanation. The explanation is like this: that there are 10 people. I'm choosing 10 people out of 16 people at one table for one table number 1, and in that table number 1, those people are sitting in circular way. So the number of ways the permutation are possible is 10 minus 1. It means 9 factorial ways, and the rest of the 6 people can be chosen by 66 ways only. I mean, it means 1 way only. And they can sit around a round table by using 6 minus 1 factorial. It means 5 factorial ways. I hope whoever have already went through my previous video on circular sitting, they understood this explanation. Okay. And if you haven't yet, then please go through again and you'll understand quite easily. Okay. Fine. Let's move on to another problem. Okay. My next question is, there's a word, for example, Talla. Okay. So how many ways we can arrange this word that no vowels will be sitting beside each other? No vowels will be sitting beside each other. No vowels will be sitting beside each other. Okay, here's my question. Go ahead and try to solve this. I'm giving you some time to solve it. Okay. Enough time have already given, so let me solve it for you people. So how to solve it? So first we write down all the uh, consonants first. So T, L, L. Oh my God, Deepak, no, 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 no. This will not be the answer. This will not be the answer, Deepak. So T, L, L, uh, H, S, S. Okay. I hope Deepak, you got this. This is the number of consonants present. So how many ways the consonants can be arranged in between themselves? So one, two, three, four, five, six. Six consonants are there. So six factorial by, because two, two particular letters are repeated twice. So two factorial by two factorial for this arrangement of only consonants. Now, how many places will be in between the consonants? There will be total 1, 2, 3, 4, 5, 6, 7 places. All right. So out of 7, we need to choose only 5 places, because 1, 2, 3, 4. Actually, 4 places. So 7C4 places will be, we need to choose, in between which these vowels will be taking place. Okay, so 7C4 places will be there, and among these 4 places, they can be arranged by 4 by 2 factorial into 2 factorial ways. All right, so this will be the answer. This will be the answer for the particular problem. All right. If you have understood, just let me know in the comment section. I hope Deepak understood this problem correctly. Okay, Deepak got it. Thank you, Deepak. So 4 places are available for the vowels to take place, and each vowel is repeating twice. So there are 2 vowels altogether, A and A. So A and E. 4 vowels, so 4 factorial ways in between arrangement, and as it is repeating by themselves, so internal permutation will not be counted. So it will be divided by 2 factorial, and for the case of A as well as 2 factorial for the case of E. As same as we have, eliminate the possibilities of internal permutation between LL and SS, like this place. Okay, so this will be the answer. So let me erase this and let's move on to the next problem. Just a moment. Okay, let me erase it. So I erased the board. Now the next problem is there is a deck of cards. I hope you all have seen or played cards before. So there's a deck of cards, deck of sorry, deck of 52 cards rather. There is a deck of, just a moment. Okay. So there is a deck of 52 cards. Okay. So how many ways we can set an arrangement of 3 diamonds and 2 clubs? This is my question. So how many ways we can pick the cards that 3 diamonds and 2 clubs will be selected? I hope you all have played or seen cards before. So I hope you are understanding how to do this problem. So I hope Deepak may answer this question as well. Right, Deepak, absolutely correct. This will be 13C3 into 13C2. This much number of cards will be there available. So why is it so? Let me tell you that there are 4 different types of cards: hearts, clubs, diamonds, and there is another type of card that is called spade. So there are 4 different types or signs of cards are available. Now each of those sign are actually 13 cards are available for each of the signs. So there are 13 diamonds card are there, and 13 clubs are also available. Four different sets of 13 clubs. So 4 into 13 is 52 cards altogether, and out of which we need to choose 3 diamonds and 2 clubs. In how many ways it is possible? So the answer will be, of course, 13 choose 3 multiplied by 13 choose 2. I hope you people got this. Fine. Okay. Let's move on to today's last problem. And this much problem is quite enough for undergraduate course in the case of permutation and combination. In order to understand this, these are the basic problems. So we can go into depth of problems always there are difficult and tricky problems, always are there, but it's not possible for me to provide all the solution in YouTube videos within a few days. So I'm focusing on best of the problems. Uh, I mean, certain set of problems which are classic problems, and those kinds of if those kind of problems, if you solve those problems, then the understanding, the basic understanding in order to solve any kind of permutation combination related problem, the foundation is will be made strong. Okay, if you solve these problems properly. Okay, so this problem is very simple one. That is just a moment. Okay, so there is a lottery is going on. All right, Deepak. No issues, no issues. This is my last question that I'm doing. So this is my last class. Last, I mean, this is the only session that I'm making today. Okay. So the thing is this, that uh, what is the chance? What is the chance of a lottery, winning a lottery uh, out of sorry out of six numbers, out of six numbers in 49 lottery tickets. Lottery tickets. Okay, I hope you already got the question correctly. What is the chance of winning a lottery out of six numbers in 49 lottery tickets? I mean, if six numbers are picked out of 49 lottery tickets, then what is the chance of winning a lottery? There's my question. So this problem is directly linking to the problems of probability. So the next session will be on probability. So this is the last session on simple combinatorics. The next session will be on probability. So we will be doing and solving the problems of probability, and we will be also explaining, I mean, different kinds of probability that are in undergraduate syllabus. No, Deepak, the question is something else. I mean, you are close, but the question is what is the chance of winning a lottery? So you are almost close to the answer. Okay, so let me do it for you. So the answer is 1 by 49 C6. Okay. The question is why? Because only one ticket may win the lottery, right? Not every ticket can win. So what is the sample space for everything? I mean, what is the sample space for the number of tickets? That is, we need to choose six tickets out of 49. So these are the number of ways we can pick the tickets, six tickets, and out of which only one ticket can win. So this is the probability, this is the chance. Okay, so this is the answer. So this problem is directly linking to the problem of probability. So the next session will be on probability. I hope Deepak have understood this. It's very simple one actually, if you understand this. So thank you very much for attending this session, Deepak. And the next session will be on. I mean, I'll let you know all when will be my next session, and the notification will be available on your, YouTube notifications. And thanks very much for attending the session. like this video, share my channel with your friends, whoever is interested in discrete mathematics and theoretical computer science. I'll also try to share some different kinds of subjects from this later of this month, or maybe from next month onwards, different kinds of subjects in computer science. Not only I might not remain only in this theoretical computer science. So I might expand the boundary on this subject. So thank you very much, and please subscribe to my channel, like my video, and share it with your friends.